Hey everybody, before we dive into the free arithmetic GMAT course, I just wanted to provide some brief background on where these videos are coming from and what we do. So we run affordable test prep websites. We have been doing the GRE for 5 or 6 years now, and we recently launched a GMAT product, which is, it's nearing, I wouldn't say it's nearing completion, but we're making a lot of progress on it. Right now, it's only $3 per month. Once the content is more like fully fleshed out, we're probably going to go to about $10 per month. We're going to give you plenty of warning about that if you do sign up. Anyway, that doesn't really matter because you are looking at a free GMAT arithmetic course. I just wanted to provide some context on where this is coming from. So if you click on Learn, so this is a list, kind of like almost like an Excel spreadsheet of all the videos. And the videos you're going to be watching are coming from arithmetic. And so I'm going to be launching the first 7 videos. I'm probably going to be launching weekly. I don't know exactly what schedule I'm going to be doing, but when the course first launches, you're going to be getting the first 7 videos. And if you click on any one of these on the website, not on YouTube, you will see the video that you will watch on YouTube as well. Also the quiz. I'm going to put the quiz in the pinned comments or the description so you can take that. That'll be free as well. And if you actually go to the website, we will have this, kind of a recap of it. But yeah, so that's basically where all of this is coming from. Like I said, I plan on putting all of the arithmetic videos on YouTube. There's like over 100 of them. The algebra section is also fully finished. The statistics and data section is making good progress as well. And if you do end up subscribing to the website, you have a study plan that you can follow, so you're just not bombarded with a bunch of videos. And the study plan, the videos for arithmetic are through modules 1 through 4. And if you just open up a module 1, for example, you can see the videos. These are the videos that I'm uploading right now, the first 7 videos. And yeah, so it's more structured, but YouTube isn't bad either. And like I said, it's free. We also have some memorization tools, GMAT cheat sheet, the GMAT mountain, some practice problems, and a bunch of quizzes. So if you guys are interested in signing up for this platform, that would be awesome. Like I said, we do affordable GMAT and GRE prep. And I just thought I would put all of the arithmetic videos on YouTube so you can get a sense of what we offer. But at the same time, even if you don't sign up, no big deal. I think, or at least I hope, that this series will improve your arithmetic and will just make you better at math in general, which will obviously improve your GMAT score. Okay, I won't waste too much of your time. I hope you enjoy the series. Hey everybody, welcome to the GMAT course. So where exactly do we start? If we have to learn all of this math in order to get the GMAT score that we're looking for, what is a good starting point? I think the best starting point is talking about the different types of numbers that we could encounter on the test. And yeah, they can be really confusing. I mean, they can just seem kind of like a jumbled mass of different things and like what exactly is going on here. So my hope is by the end of this video, you have a better sense of the categories that we organize these numbers into, and you have a better sense of the kind of numbers you're going to encounter on the test. So let's go ahead and dive into it. We're going to start from the easiest category and move to the harder categories, but even the harder categories hopefully won't seem that challenging. All right, let's go ahead and dive into it. So first of all, let's start with numbers that appeal to us almost instinctually as humans, and these are going to be what we call the natural numbers. Another word for these are the counting numbers. So like I said, these are things that just appeal to us, like I said, instinctually. These are things that a toddler could even pick up on. The counting numbers, of course, 1, 2, 3, and we can just go all the way to the right to infinity. I'm going to stop at 19 because obviously if I went to infinity, we would die and be here forever. So yeah, these are the counting numbers, the easiest categories. All right, so let's now talk about the second easiest category. It's going to be what we call the whole numbers, which is very similar to the natural numbers, the counting numbers, but we include a very important element, and that element is 0. And the reason why we want to separate this is because 0 is not something that humanity came across easily. In fact, there's a book, a famous book called I forget exactly what it's called, but it's basically talking about how we discovered zero and how for a long time zero is demonized and evil, and people didn't really understand what it was. And we didn't really acknowledge its true power until relatively recently in human history, which is surprising to a lot of people because zero is an extremely useful number in a variety of different contexts. So far we've seen the counting numbers, the natural numbers, and the whole numbers, which include zero. So now let's expand this even further. And what we're going to do is talk about the integers. So the integers, again, include zero and all of the counting numbers, but we're now going to add the negative counterparts. So we don't just have 1, we have -1. We don't have just 2, we have -2. Keep in mind, 0 is neither positive nor negative. So it's kind of like the boundary point, if you want to think of it that way. And just like the positive counting numbers, when we went to the right, we could go to infinity. We can do the same thing with the integers. We can go to negative infinity to the left. And again, I don't want us to die and turn into skeletons, so I'm just going to stop at -19. So let's take stock of what we've seen so far. So we've seen numbers that kind of are clean. Clean numbers are ones that we can count on our fingers, or even in the negative case, we can still kind of like say, oh yeah, we have 5 negative numbers. It's pretty clean, right? So what makes it, like, what's the next step in the complexity level? So that's going to be the rational numbers. I want you to focus specifically on the word ratio. So rational numbers are numbers that can be written as a fraction. 1/2, for example, 3/2, for example, 3/2, for example, 5/3, for example. And of course, we can write every single rational number in decimal format. We'll talk about that more later. But take, for example, 5/3. As a decimal, we write it as 1.66666666666. But of course, we don't want the 6 to go on forever, so we put that little line above it. That means it goes on forever. Yeah, so even like 3/2, we could write that as 1.5. 1/2, we could write that as 0.5. Another thing to keep in mind is every single integer is also a rational number. You can write the integers as a fraction. It's not very useful, but you could. So take, for example, -2. You could call it -2/1. Or if -1, -1/1, or 3, you could call it 3/1, or 4 is 4/1, or even 0, 0/1. So all of the integers are also rational numbers. Okay, so what do we talk about next? If we have the rational numbers, and these are numbers that can be written as a fraction, what do you think irrational numbers are? What do you think? These are numbers that cannot be written as a fraction. Probably the most famous example is pi. If you remember that from junior high or whenever it was you studied it, pi is the number that is created when you take the ratio of a circle's circumference to its diameter. If you don't know what that means, don't worry, we'll probably talk about it later. But keep in mind, irrational numbers cannot be written in decimal form, or at least not cleanly. So that's why with pi, we have to say it's 3.14 approximately. Do you see these little wavy lines? That means approximately. Now notice we could keep those decimals going forever, but there's no pattern to it. Do you remember the previous example, the 1.66666? There's obviously a pattern there. The 6s are repeating forever. But in this case, we don't even know what these decimals are doing. I mean, we do if we calculate them, but the point is, if we keep calculating them forever, we're never going to find a pattern. It's wild. It's crazy. Pi is probably the most famous example. Another really famous example is going to be the square root of 2. That's another really famous example. That approximately equals 1.4. A lot of square root values are going to result in irrational numbers. If you don't know what a square root is, we will talk about that when we talk about roots. But these are just examples. Now, a lot of people will say, well, wait a minute. You said an irrational number cannot be written as a fraction. Why can't I just do, for example, pi over 1? Can't I do pi over 1? Well, the problem here is, in order for something to be a fraction, both the top and the bottom have to be integers. And notice pi is not an integer. So this is not a fraction, everybody. This just means pi divided by 1. It's not an actual fraction. Let's summarize. What are the natural numbers? These are just the counting numbers. What are the whole numbers? Those are the counting numbers with 0 included. What are the integers? Those are the whole numbers with the negative counterparts included. What are rational numbers? Any number that can be written as a fraction. What is an irrational number? Any number that cannot be written as a fraction. And there you go. That is your introduction to the different types of numbers you're going to encounter on this dang test.